Assalamu alaikum warahmatullahi wabarakatuh. Students, in this video we are going to learn about the 18.2 in your chapter number 18 about energy, right? Before this, in 18.1 we learned about the work. Now you know what is work, right? If you want to define the work, you have to talk about the an object which has been displaced by a force, right, for a displacement of d. Okay, for a displacement of d, right, the work done, here the work done is equal to the force into the displacement d. Right, you learned about this. Now you know, if you want to do a work, right, there is a requirement, right? If you want to really do a work, if you want to carry something to one place to another place, right, you need a requirement. That requirement is the energy, right? If you are doing a work without an energy, you can't do that work, right? Normally, to do work, right, the energy that has been already created as chemical energy, which has been stored in all the substances, right, within the bonds that formed by the substances. For an example, if you take glucose that we are consuming as a source of energy, right, which is going to provide you like this. There are numerous bonds, right? Those bonds are going to provide us but the energy. Okay, by breaking these bonds, we can release energy, and those energy are known as the chemical energy, right? Those chemical energy is required, right, to do a work, right? Once you did the work, again that work will be stored as an energy, as a type of another energy, right, within the object, right? That's why Sir Albert Einstein said, energy cannot be created, right? You need energy to do work, right? But that energy cannot be created. You can't create it because that has been already created by Almighty, right? We need to use those energy, right? We cannot create the energy. At the same time, we cannot destroy the energy as well, right? Once you start to use the chemical energy, those chemical energies are going to be exist in the world, right? It cannot be destroyed, right? But it can be changed from one form to another form. For an example, you can change the chemical energy as electric energy, right? You can change the chemical energy as heat energy, right? You can use the chemical energy as another type of energy, right? But this chemical energy cannot be destroyed, or the energy cannot be destroyed, right? It can be interchanged, right? Right? We can introduce this work as an intermediate, right, which is contribute to change an energy, a form of energy to another form of energy, right? Therefore, the work is also a type of energy which is an intermediate to change the energy from one to another one, right? I'll explain you later, inshallah, in next year. You will be learning not the next year, in this year, right? In the grade 11, right? You are going to learn this in great detail, inshallah, when you learn heat energy and something, so on, right? Okay. Now, here, chemical energy, the work and the energy, right? Now, you know what is, you can make a small idea about what is the energy means, right? The energy is the requirement to do the work, okay? At the same time, once you did the work, the energy which has been used, right, cannot be destroyed. Therefore, that energy is going to be stored in the substance, in the object that we are dealing with. Okay, right. Now think about a coconut tree. Right now, a small coconut tree. Have a small coconut tree. Right, coconut is there. Now, if this coconut fall down, right? Once it reached the floor, right? At that time, if you try to consume that energy, right? In other words, we can say, if you keep your head here, right? Then the effect made by this coconut, right? You know that is not equal by the coconut which is taller than this, right? Going to make, right? You may say this coconut is going to make the more effect than this coconut. You think the coconuts are equal in size and the mass, right? If the mass and the size are the equal, right? The effect made by this coconut is not equal to effect made by this coconut. The effect of this coconut is going to be high, right? In other words, we can say, right, in scientific term, more energy is going to be given by this coconut than this coconut, right? Therefore, the energy stored in this coconut, right? The energy stored in this coconut is more than this coconut, right? Another term, in other words, we can say, if you keep an object in a place, in a higher place, right? Some sort of energy is going to be stored in this substance, in this object, right? If you increase, while you increase the height, right? The energy stored getting increased, right? This type of energy, due to the position of the object, right? This type of energy is known as potential energy. You can see this, right? This is due to the position. How this energy has been stored, right? That is a very important thing, right? Now think about an object. You are going to keep this object from this place to a high position, right? Now, if the mass of the object is this, then the weight which is going to apply downwards, the weight is going to be equal to mass into gravitational acceleration, right? In other words, we can say a type of force which is due to the gravitational force, right, is going to act downwards. If you want to really uplift this object, right, you have to give a force which is more than or very equal to what this weight, right? Then only you can start to lift it, right? The minimum force that required to lift this is the weight, right? If you use more than the weight, then you can accelerate the object upwards and you can take the object up, right? We will say the minimum force of mg that you are using here, right? At the same time, the height that you are going to lift is h, right? Then the work done here, right, using your chemical energy, which is stored in inside you, right? You are going to do a work, right? The work done here is going to be equal to the force into displacement, What is the force that we are using? The minimum force of mg. What is the displacement that you made? That is the height, right? That is the displacement. Then the work done is going to be equal to mg into h, right? The work done is going to be mgh, right? Which means this amount of energy that has been used from our body, right? Used from the chemical energy which has been stored in our body, right? And we did the work, right? Therefore, that chemical energy should be stored, right, at this position. When you take the object to this position, right, it should be stored inside the object, right? Therefore, that energy is going to be stored when you uplift this object. If you uplift more high, this H component is going to get increased, right? That is going to tell you if you want to uplift more high, right, then you have to do more work. By doing more work, you are going to store more energy when you uplift the greater heights, right? Therefore, by the position, right, we are storing the energy by uplifting the objects, right? That energy, I told you, that is the potential energy, right? By this equation, the potential energy can be measured. That potential energy is equal to mass of the object into the gravitational acceleration and the height we are considering that object, right? So the potential energy is going to be equal to mgh. Someone asks you, right, what is the potential energy that has been stored in the coconut tree? Coconut here is going to be potential energy of this coconut tree is going to be mg into the height. If the height is h1, then h1. What is the coconut tree if the height is h2, right? What is the energy stored in this coconut? It's going to be mg into h2. That's it, right? That is the potential energy. This potential energy, the term potential energy, is a basic type of energy, right? This can be seen in everywhere, right? In every object, right? The potential energy is going to be there. Okay. Now we'll think about this is immobile. We are talking about the not immobile. We are talking due to the position of the object, right? We are talking the energy stored in the inside the object, right? What about the moving object? Now think about an object. Which is going to start to move. The initial velocity is 0. Now it's gradually increasing its velocity, right? Which means with a constant acceleration, if it is increasing its velocity, right? After a while, we think about a velocity that has been gained by this object is v, right? Now you know at this position, this object is going to have a velocity of v1, which is the v1 is going to be less than v, right? This is the more velocity because this is accelerated. Therefore, the v1 is going to be less than the v, right? If you collide with this object at this position, right, it's going to be less harmful than colliding at this position, right? Because the velocity is high. We are saying the velocity is high. Then we are considering a type of energy, the type of energy which has been stored inside this object, right, which is related to the velocity, right? By increasing the velocity, the energy stored inside the object getting increased, right? Therefore, by the movement, right, we are considering another type of energy. That energy is known as kinetic energy. Kinetic energy. What is that kinetic energy? How we can find this? Right? We'll see. The same thing. The work done is equal to force into displacement. Right? We'll take this displacement. We'll take this displacement as d. force is there. Without a force, you can't accelerate the object, right? For the force, I can say if the mass of the object is m and the acceleration is a, then I can say the force, the unbalanced force act here is going to be m into a, mass into acceleration, right? Therefore, right, instead of this F, the force, I can substitute mass into acceleration. Keep this in your mind. The second thing, for the displacement, I am going to use S is equal to ut plus half at squared equation. S is equal to ut plus half at squared equation, right? You know the u is 0. Therefore, this component is going to be 0. The displacement is d. Displacement made is d, right? Into this component is going to be 0 plus half into acceleration into t squared, right? Half into acceleration into t squared. I'm sorry, I'm not using this equation. I'll use this equation. V squared is equal to u squared plus half 2a into s. The final velocity after this displacement is v squared, v, then the v squared is equal to u. The initial velocity is 0 plus 2 into acceleration into the displacement d, right? Therefore, I'll take a value for t in terms of this. Then the d is going to be equal to v squared over 2a. I'll substitute this here for this d, right? Then that is going to be v squared over 2 into a, right? If you cut off this a and a, right, then the remaining part is going to be mv squared over 2, right? That is the work done. This can be written as, if you take this 2 in front, then half into mv squared, right? This work done, that is the work done to take this object from this place to this place, right, with the velocity of v. The final velocity that you have been gained is going to be v, right? This energy has been this is the energy that has been stored inside this object due to this velocity. We are calling this as, but that's kinetic energy. Therefore, the kinetic energy can be illustrated. Kinetic energy is equal to half into m into v squared. Right? Take down the notes and do the exercises that is there in your book, right? And send it to me, inshallah, today itself, inshallah.